Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Faiz, and this is my group member, which is Adam, Aiman, Razin, Abdul Muaz, and I. We're going to present about the practical 7, and we were from group 4. We move to the other slide, which is the introduction. For this practical, we introduce the HVAC. HVAC system are responsible for regulating the comfort levels of most indicators environment. And the chiller plant acts as a centralized cooling system, which is provides cooling for a building or a number of a building. According to the Energy Star website, around 39% of buildings which are more than 100,000 square feet in size of a chilled water system and through chiller or air conditioning units. And the main component in HVAC is the compressor, the condensing coils, and the metering device, and the evaporator. So there's a simple sketching of the HVAC system. And then our objective is to identify the type of chiller used in utilization biodiesel pilot plant in the market. And the second is to understand the function of chiller system in a biodiesel plant. And lastly, we want to measure the energy usage by 8 hours per day for a chiller in biodiesel plant. So for the theory, is the refrigeration cycle is the process of heating and cooling the refrigerant and converting it from gas to a liquid and back again. And the refrigeration cycle starts with appropriate pressure liquid or gas mix entering the evaporate. And in the evaporator, the heat from the processed water or water glycol solution boils the refrigerant, which changes it from low pressure liquid to a low pressure gas. And the low pressure gas enters the compressor where it is compressed to high pressure gas. And the high pressure gas enters the condenser where ambient air or condenser waters remove heat to put it to a high pressure liquid. And that's the figure of the vapor compression refrigeration cycle, which is consists of 4 main parts, which is condenser, compressor, evaporator, and the expansion valve or other. And the procedure is our simple procedure, which is one is employees through cylinder process turning, and also we want to freeze safety industrial chiller also can equip with a low temperature sensor. The freeze safety device detect low thermal level and switch off to prevent the refrigerant from freezing over. And then the compressor safety features. Compressed unit are a key part of a refrigerator system, including those in chiller unit. And to ensure the compressor which is kept within safe limit, most units are manufactured with 3 safety features, which is one is high pressure cutout, secondly is low pressure cutout, and 3 is low oil pressure cutout. And lastly is the flow safety thermostat, which is a vital safety feature in industrial chiller, is the flow safety thermostat. And this device detects adverse change in temperature within the refrigerator circuit when unfavorable thermal conditions are arise with the chiller refrigeration unit. And the flow safety sensor will detect it and cut off the coolant circulation. Thank you.
So bismillahirrahmanirrahim, untuk observation untuk praktikal ketujuh ini adalah, so based on observation, the experiment is to identify the type of chiller used in biodiesel pilot plant. So chiller yang diguna pakai pada pilot plant tu adalah sejenis water chiller. So the chiller ni adalah terletaknya sama di dalam kompresor, di bilik kompresor. So di chiller ni juga adalah dia punya sifatnya ataupun dia punya objektif dia adalah untuk membuat cooling. So sekiranya nak membuat cooling pada temperature dan ketika itu cooling tower tidak berfungsi ataupun kondisi air cooling tower tidak baik, so kita boleh guna pakai pada air chiller tersebut. So the consume of power of chiller is 3000 watt. So torque is 14.35 Newton meter of torque and speed is 1638 RPM.
So for the result of the chiller experiment, this is the recorded data that have been obtained from the chiller. So the chiller specification is, the power rating is 3000 watt with torque of 14.35 Newton meter and then the speed of 1638 RPM. And the inlet temperature is 43 and the outlet temperature is 27 with a room temperature is 31 degrees Celsius. So using the angular velocity formula, which is equal to RPM times by 2 pi over 60, and then we obtain the speed amount 1638 and submit it into the formula. We get the angular velocity about 171.53 radian per second. And then for the power mechanical output is equal to torque and times by radian per second. So the power mechanical output can be calculated using the torque, which is 14.35, and times by 121.53, which is the angular velocity, and the power mechanical output is 2.462 kilowattage. And for the COP of chiller, the formula is power mechanical output divided by power rating and times by 100%. And then the power mechanical output is 2.462 kilowattage. It's divided by 3 kilowattage, which is the power rating, and times by 100, and we got 82.05% of COP for chiller. And the cost power rating is times by 8 hours, and the C1, okay, tarif C1. So the cost is equal to 3 kilowattage, and then times by 8 hour and times by 0.35, and we're gonna get a total cost in about 808 ringgit and 76 cent per day.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Zuri bin Muhammad Samri, CN190116. So I'm going to present about the discussion for the chiller lab, that is lab 7. So as a result of the chiller experiment, the temperature has been divided into 3 categories. There are 3 temperatures: inside, outside, and room temperature. The inside temperature was 43 degrees Celsius, while the outside temperature was 27 degrees Celsius. So the temperature in the room is 31 degrees Celsius, while the power rating was 3000 watt. So the torque was 14.35 Newton meter torque, and the running speed of the chiller was 1638 ppm. So the chiller plant serves as a centralized cooling system that cools an entire power plant. So this is due to the fact that it is often more practical to centralize air conditioning equipment in one location rather than installing numerous pieces of equipment in various locations. So the cost of the chiller in the utilization power plant is calculated using tariff, and it is 8.76 ringgit per day, calculated using the power rating and the hours of usage. So the lower the energy charged by the utility during peak hours when compared to the tariff scheme. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So this is conclusion for experiment number 7. So finally, the electricity and chill water produced did not strictly adhere to the design condition. The main issue was there were not enough electric chillers capacities. If additional chillers and thermal storage tank are added to the system, more balanced scheduling that can be optimized plan operation can be achieved. Through the examination is required to determine the additional capacity of electric chillers and thermal storage tank that could meet the requirement. A chiller plant and thermal energy storage could be managed to turn on and off in a looping distribution cooling supply to distribute chilled water to air handling units. That's all for me.